today in an age of science, and we're dazzled by the vast technology it has created. But the elaborate paraphernalia of the scientist is nothing more than a tool for thinking, for a systematic way of looking at things and thinking problems through that we call the scientific method. It is this that has given us the remarkable achievements of science in modern times. What is this scientific method? We know that a scientist gains knowledge through observation of physical facts. He employs many devices, from the microscope to the atom smasher, to look at physical objects and events. He works with intricate measuring and counting devices. He makes use of any number of experimental techniques. But all of these are merely aids to observation. Most important of all, a scientist has to think about what he sees, to reason a problem through from observed facts to observable results. To find out how a scientist thinks through a problem, let's consider an example from modern medicine. Medical science today owes much to one of the great scientific achievements of recent times, the discovery of penicillin, a wonder drug now saving thousands of lives. This is penicillin, a powerful destroyer of deadly bacteria that is produced from an ordinary mold. Until a few years ago, penicillin was unknown. The discovery was a remarkable achievement of the scientific method. It began in the year 1928 in London, in the laboratory of Dr. Alexander Fleming, a British bacteriologist. For a number of years, Fleming had been seeking a drug that would destroy types of bacteria that cause infection. Just now, he was growing a number of colonies of these infectious bacteria for his experiments. Scientists call these growths bacterial cultures. This day, he found that one of his bacterial cultures had become polluted. A spot of mold had developed in the dish, spoiling the culture. Dr. Fleming was about to throw the polluted dish away when something stopped him. He noticed that around the mold there was a ring of clear jelly, free of bacteria. Examining the jelly more closely, he began to wonder if something in the mold was killing the bacteria. Was it possible that here was a substance that could be used to prevent infection? This was a question worth investigating.
I say, gentlemen, here's something interesting. Take a look at this dish.
This? Oh, yes. It's got a bit moldy, hasn't it? That's too bad. But after all, it happens all the time.
No, take a closer look. You notice anything odd?
Why? Why?
See that ring?
Why, yes. It's clear, isn't it?
Right. I'd say something in that mold is destroying the starch in that dish.
That is interesting. What do you make of it?
I don't know. I think it's worth looking into. It looks good. Very good.
Well, I say, do you think perhaps there's something there we ought to follow up?
Perhaps. And perhaps, gentlemen, we've got a drug that will destroy infectious bacteria. But before we know, we've got work to do. Come in.
Dr. Fleming and his assistants undertook a number of experiments to test his idea that the mold might be a weapon against disease. First, they introduced the mold-infested broth into other cultures of bacteria. Later, they found that in many of these cultures, too, the bacteria were destroyed. But Dr. Fleming wondered, if it killed bacteria, might it not also be harmful to living tissues? To determine this, they injected the drug into animals. They found that the animals were not harmed by the drug. Then, mixing it with human blood, Dr. Fleming determined that it did not harm the germ-killing cells in the bloodstream. Dr. Fleming reached the conclusion that he had found a drug that would destroy bacteria and that, some evidence indicated, would not harm human tissues. He published a paper describing his experiments. But this was only the beginning. 10 years later, another British scientist, Dr. Howard Florey, conducted a number of experiments to verify Fleming's findings. and then, along with other scientists, developed penicillin as a drug of amazing power against disease. But let's review this remarkable discovery method. First, a scientist begins with the perception of a problem. Dr. Fleming had been trying to find a drug that would prevent infection. This, combined with his long training in observation, enabled him to recognize a problem in the accident of the mold polluting the dish. The second step was to make preliminary observations. This brought him to the third stage in scientific method, thinking of a hypothesis or possible solution to the problem. Now came the fourth stage of scientific method, the long series of experiments which Dr. Fleming and later Dr. Florey and others carried on to test the validity of Dr. Fleming's hypothesis. This led to the final stage, the solution of the problem. Penicillin was established as a drug of amazing effectiveness against infection. These, then, are the elements of the scientific method. First, perception of the problem. Second, preliminary observations to suggest solutions. Third, the development of one or more hypotheses. Fourth, the testing of these hypotheses through extended observation or experimentation. Fifth, the choice of a workable solution to the problem. This is the method the scientist applies to any problem in which facts can be observed, and this is also the method of common sense. Thinking people use the same method to solve all the everyday problems having to do with observable facts. For instance, scientific thinking is as necessary to a garage mechanic as it is to a scientist.
Well, Joe, she just died on me. I'd say the gas line's clogged.
You think so? How do you know?
Well, it could be, couldn't it?
Yes, it could be, but it could be any number of other things, too.
The first thing a mechanic has to do is determine what the problem is. Next, he makes a preliminary investigation to find possible solutions. Then, he develops his hypotheses. Next, he tests these hypotheses, discarding them one by one if they prove false. Until finally, he hits upon the right solution to the problem. With problems of this kind, of course, almost everyone tries to think systematically. But some people find it hard to apply the scientific method to all the other problems that can be solved through observation and experimentation.
Did you hear? There's another epidemic down at the south end of town.
Oh, how terrible. You know, I think the town ought to do something about conditions down there.
Do something? What can they do? Look at the kind of people that live down there.
People? What do you mean? You can't just blame people for bad living conditions, for filth and disease and things like that.
Oh, I think you can. After all, that's the way that kind of people like to live.
I'm not so sure. I think the town ought to do a study of those conditions and get at the cause of it.
Some people let prejudice dictate the answers to problems. But thinking people realize that solving such problems requires systematic observation and the gathering of many facts. All the factors bearing on the problem have to be investigated. Then, the facts have to be studied to find the best ways of solving the problem. And finally, the most promising solutions have to be tested in practice. This scientific method of thinking applies to any everyday problem which lends itself to observation and testing, to problems of business as well as to problems of family life, to problems of law enforcement as well as to problems of making the decisions of the community. This is the method of common sense thinking fully as much as it is the method of science. But the scientist uses this method for a deeper purpose, to gain an understanding of the world in which we live. For instance, long before men were able to combat disease, the causes of disease had to be discovered through years of scientific investigation. The French scientist Louis Pasteur began his work as a practical effort to stop the diseases attacking silkworms and certain animals in France. Systematic observation led him to the hypothesis that the cause of disease might be found in the bacteria present in diseased organisms. He devoted much of his life to testing this hypothesis, to a succession of careful experiments with animals. This intensive experimental work eventually enabled him to establish his hypothesis as a demonstrated theory that bacteria are, in fact, the cause of disease. This scientific discovery brought about a revolution in the practice of medicine, enabling modern medical specialists to make great advances in understanding and conquering disease. Keen perception of problems, careful observation, imaginative development of hypotheses, rigorous testing and experimentation, choice of the most workable solutions. These are the steps essential to the scientific method of solving problems. And while most of us are not engaged like the science in the mysteries of the universe, we still may use his method in everyday life. For this, the scientific method is a tool for clear and effective action.